Hello and welcome to this tutorial on how to build your Unity project to install it on the Microsoft HoloLens. First of all, make sure that you have the necessary components installed. For Unity, this means that you need to install the Universal Windows Platform build support and the Windows build support with IL2CPP. You will also need Visual Studio 2019 with the workloads for desktop development with C++ and the Universal Windows Platform development. Make sure to also check the Windows 10 SDK and the Universal Windows Platform workload, as well as the USB connectivity and the UWP tools for C++ version 142. When choosing the game development with Unity, make sure to uncheck the Unity editor, or else it's going to install a second instance of Unity. It is only possible to build HoloLens apps on Windows 10 PCs. I will demonstrate the build process in this video with our application VIAProMa, but it works the same way for any other application. To keep this tutorial to the point, I will only show the build process itself, so you should already have a Mixed Reality project that is configured with the Mixed Reality Toolkit. As the first step, open the build settings by going to File, Build Settings. Make sure that all scenes that will be visible at some point during the application's runtime are included in the Scenes in Build list. You can either add currently open scenes by clicking the Add Open Scenes button, or by dragging and dropping a scene file into the list. HoloLens apps are Universal Windows Platform apps, so we need to switch the platform. Select the Universal Windows Platform and click the Switch Platform button. The build process contains two steps. First, we will build the Unity project. This will generate a Visual Studio C++ solution, which, in turn, we also need to build. You can automate these steps using the build window of the Mixed Reality Toolkit, or you can follow them manually. First, I'm going to show you the build window of the Mixed Reality Toolkit. Here you can directly generate an installer file with one click and then deploy it to the HoloLens. You can find the build window under Mixed Reality, Toolkit, Utilities, Build window. It consists of 3 tabs which you should follow left to right. In the first one, the Unity build options, you can set the target device to either any PC or HoloLens. There's no need to hit the build button here, as the next step will automatically take care of this. So switch to the AppX build options. Here, set the build configuration to release. This option is more performant than a debug configuration. Set the build platform to x86 if you are targeting a HoloLens 1 device, or either ARM or ARM64 to deploy to HoloLens 2 devices. Since I'm targeting the HoloLens 2, I choose ARM64. If you check multi-core build, the build will use multiple CPU cores. If you need gaze input on the HoloLens 2, there's also an option here to enable it. Finally, you can hit the Build AppX button to start the build. Since we skipped the Unity build, it will ask us whether we want to do this step first, and we say yes. One thing to note is that you should clear your build folder before creating a new build. Sometimes Unity does not properly update existing builds, so it is best to start with a fresh build. Next, switch to the Deploy Options tab. If you are connected via Wi-Fi, switch the target type to remote. For a USB connection, set it to local. Here I have the HoloLens in the same network, and the network allows devices to communicate with each other, so I can set it to remote. Next, enter the IP address of the HoloLens. To find this, switch to the HoloLens and open the Settings app. Go to the Network and Internet settings and click on the Advanced Options link of your currently connected network. If you scroll down, you can find the IP address that your HoloLens has in the local network. Back in Unity, enter the IP address and the credentials of your device portal. If you've not used the device portal before, you can enable it in the developer settings on the HoloLens. If you enter the IP address of your HoloLens in a browser, you will be able to set up the credentials. In Unity, if you click Refresh Builds, your created AppX packages should show up. You can test your connection to the device portal using the Test Connection button. If you have trouble connecting, it might help to disable the Verify SSL certificates checkbox or install the certificate of the device portal as a trusted source. Once the connection is successful, we can deploy the app using the Install AppX button. You can follow the installation progress on the console. Congratulations, you have now installed the app on a HoloLens. Now that we've seen the automated way within the Unity editor, we can now take a look at the manual steps. These are actually the same steps that the build window performs in an automated way. So we start in the build settings window under File, Build Settings. Here you can find similar configuration settings to determine how Unity generates the Visual Studio solution. Copy the shown settings. The target device should be set to any device or HoloLens. The architecture does not really matter at this point, as we can change it later. The build type must be set to D3D project. The two SDK versions are critical for the success of the build, as wrong versions here will exclude necessary features from the final app. For the target SDK version, keep it at latest installed. This will default to the SDK that you installed with Visual Studio's UWP workload. The minimum platform version must be kept at 10.0.10.24.0.0 and cannot be raised. Keep the Visual Studio version as latest installed so that Unity generates the solution for your newest Visual Studio version. You can set the build and run to USB device and the build configuration to release, but these two options can also be changed later in the generated solution. We are now ready to build the Unity project. So click the Build button. Choose a folder where you want to generate the solution. I recommend creating a build folder in your project's root folder on the same level as the assets folder. This way you can, for example, exclude the build folder from your source control. One important thing to note is that you should build into an empty folder and not overwrite an existing previous build. If you overwrite a build, the process will still work, but Unity sometimes does not update every file, like the project settings, and you end up with a strange mixture of the two builds, where not all of your latest changes are applied. So make sure that your build 100% reflects your current Unity project, and delete any previous builds and choose an empty folder to build in. Now wait for the build to finish. This can take a couple of minutes. When the build process finished, check the Unity console to see if there are any errors. If the build process was successful, an Explorer window will open up with the generated solution highlighted. Note that this generated solution is different from the solution that you can find in the project's root folder, which administers the C# scripts. Make sure to open the one from the build folder. In Visual Studio, there are now two options for building the application. The one that you will find in most documentations is to change the configuration here on the top bar and to build and deploy directly to the HoloLens. I will show you this option and the second one, which generates an installation file that you can also pass on to others. Okay, so in this first option, change the configuration from debug to release. This switch improves the performance considerably. If you are targeting the HoloLens 1, change the target architecture to x86. For your HoloLens 2, you need to choose either ARM or ARM64, where ARM64 is recommended. At this point, you also need to connect your HoloLens to your PC using the USB cable, or make sure that it is connected in the same local network. For the network, it is important that your devices are allowed to communicate with each other. Some public networks, for example at the university, do not allow this. The HoloLens should also be turned on during the process. With a USB connection, you need to select the device target. For a wireless connection in the network, you can also use the remote device option. Finally, start the build with the automatic deploy using debug, start without debugging, or hit Ctrl F5. The solution will now start building, and when it is finished, it is deployed to the HoloLens. After the installation, the application automatically launches, but it can also be found in the app list where you can start it in the future. An error that you might encounter in the end of the build is that the deploy failed. This is most likely due to the fact that the HoloLens went into standby mode at some point during the compilation. To avoid this, you will need to make sure that it is active when the build is close to completion and when it tries to deploy the app. To avoid it, you need to monitor the compilation process for the entire time to keep the HoloLens alive at the right time. I recommend an alternative option. Instead of directly deploying to the HoloLens, you can also create an app package to install it. This is the same result that you also got via the build window. You can start the generation of the package, leave for a coffee or do something else in the meantime, and get notified by a pop-up once the build is finished. It also allows you to generate the packages for HoloLens 1 and 2 in the same build process. To create the package, right-click on the project with the application name in the Solution Explorer, so in this case VIAProMa. Then choose Publish, Create App Packages. Next, select Site Loading. On the next screen, make sure that you select the architectures for which you want to build, so x86 for HoloLens 1 and ARM or ARM64 for the HoloLens 2. If you only want to build for HoloLens 1 or HoloLens 2, you can of course exclude the other ones. Make sure to switch the configurations to the selected architectures to release. If you want, you can set the Generate App Bundle option to always. If you have selected both architectures for HoloLens 1 and HoloLens 2, this will create one bundled package which can be installed on both devices. If you are only building for one device type, you do not really need this option. Finally, click the Create button to start the build. Once it is finished, a dialog Finished Creating Packages appears. You can just close it. The next step is to install the package on the HoloLens. This is best done with a network connection to access the device portal, but it is also possible to do it using a USB connection. Look up the IP address of the device as shown at the beginning of the video. Enter it in a browser on your PC to get access to the device portal. You might face a security warning that the SSL certificate is unknown. You can either ignore this message or install the certificate of the HoloLens. Enter the credentials of your device portal. Next, go to View Apps. If a previous version of the app with the same version number is already installed, make sure to uninstall it first. Look for the app in the drop-down menu and click Remove. This step is not necessary if you have increased the version number, since a new installation will then replace the old one. The actual installation now happens by clicking the Browse button. Go into the Builds folder and navigate to the App Packages folder that was created by the Visual Studio build. A couple of folders further down, there is an AppX file that starts with the application name and the version number. Select this one for the upload. If you have not installed the application previously, you also need to check Allow me to select optional packages. Then click Next. Again, click the Browse button and now go into the Dependencies folder. Navigate into the folder which corresponds to the target platform of your build and select the present AppX file. Click the Install button and wait for the installation to finish. Your app is now installed and can be found in the application list on the HoloLens.